Okay, so it looks like I may be alone for this one. So one of the big things we're learning this week is solving by factoring. So this is something that you use in order to solve quadratic equations. So we need to first look at what is a quadratic equation. So a quadratic equation is one where the highest exponent is a 2. And because it's a 2, they're also called second degree equations. So the second obviously comes from the 2, and the degree part is another name for the highest exponent, so it's a degree 2. If you're wondering how we get the word quadratic, when quad usually means 4, it's because it's actually coming from made square. So it's not actually coming from the word quad meaning 4, it's coming from Latin quadratus, make square. So that's something that I have always wondered about, is why is it called a quadratic, not like maybe a bidratic or something like that. So there are lots of different forms of a quadratic equation. We've got standard form, which is ax squared plus bx plus c equals 0. We have to have it equal 0 in order to solve. There are other forms that are quadratic equations. Ax squared equals 0, ax squared plus c equals 0, ax squared plus bx equals 0. You can have it in factored form, a times ax plus b equals 0, and x plus a times x plus b equals 0. The types that we're going to be solving today by factoring are the ones in standard form, and then we can solve any that are in the ax, well, not any that are in ax squared plus c form, some that are in that form, and then any of them that are in the ax squared plus bx forms. So those are the 3 forms that you would use or you would try to solve by factoring. So in order to solve by factoring, we have to use the zero product rule. So of course we need to talk about what that is. The zero product rule says that if you have a times b and it equals 0, so 2 things multiplied to 0, then a is 0 or b is 0, because the only way to multiply by 0 is if at least one of them is equal to 0. So one number is 0 or the other one is 0. It's entirely possible for them both to be 0, but at least one of them is 0. And so that's the idea that we're going to be using here, because we're going to set things multiplied to each other and then use the fact, well, if the multiplication equals 0, then we can set each one equal to 0 to find possible solutions. So when we're solving using the zero product rule, which is the same as solving by factoring, you're going to first put your equation in standard form. Then you're going to factor, which is why we spent a whole week on factoring, because that's what you have to do for this week. And you're going to get something in the form ax plus b times cx plus d equals 0, or something similar to that. And then you're going to set each of those factors equal to 0. And that third step is the zero product rule being used. And then you solve those equations for x, because then you get linear equations and you can solve those for x, and you get 2 answers. Quadratic equations always have 2 solutions. Sometimes the 2 solutions are identical, so you just have one number and it works twice. But in general, there's going to be 2 different numbers that work in that equation, and that matches with the exponent. So the highest exponent is 2 solutions. Linear equations have no exponent, or exponent of 1, so there's 1 equation. So we're going to solve these by factoring, which means using the zero product rule. So I've got 2 examples here. Both are already set in standard form. They both are set equal to 0. So our first step is to factor. So I'm going to write that down. I'm just going to write down the steps twice here so you have that written down there. So the first one, when I factor, then I'm going to get two sets of parentheses, and then it's going to be equal to 0 because I am factoring the w squared minus 10w plus 16 part. That's what I'm factoring and putting in my two sets of parentheses. So I know it has to be w times w in order to get w squared. And then I'm looking for two numbers that multiply to 16 and add to negative 10. And that will make up my other numbers. Now, since I'm multiplying to a positive and adding to a negative, both of the numbers have to be negative. So you go through and you think what numbers can multiply to 16 and add to 10, and you go through your possibilities, and we get 8 times 2 is 16. 8 plus 2 is 10. So if I have a negative 8 times a negative 2, that gives me a positive 16. And then a negative 8 times negative 2 adds up to a negative 10. Now, I'm not going to go into much detail on the factory portion here because we did all of that last week. So if you need more help on the factoring, you can go back to those videos. So once you factor, your second step is to use the zero factor property. And that's where you set each factor equal to 0. So the first one is w minus 8. So that I set that equal to 0. And then the second one is w minus 2 equal to 0. And then you solve each of those equations. So for w minus 8, I'll be adding 8 to both sides, which gives me w equals 8. And for w minus 2, I add 2 to both sides and get w equals 2. And those are your solutions. 8 and 2 are the two answers to that quadratic equation. So we factored, then you basically take each set of parentheses, set them equal to 0, and then you solve and you get your answers. So the problem on the right, we have 9x squared minus 4. We are factoring 9x squared minus 4. We have it equal to 0. And this is a special factor. This is actually a square of two binomials. Or no, a difference of squares, sorry. The other type of square. So this factors, we're going to get a 3x times 3x to get to 9x squared. And then a positive 2 and a negative 2 multiplies to negative 4. And when you get the combination, they're going to add to 0, which is why there's no middle term. So the zero factor property then has us take 3x plus 2 and set it equal to 0. And 3x minus 2, set it equal to 0. And then we're going to solve each of these for x. So on the left, I am subtracting 2 from both sides. And on the right, I'm adding 2 to both sides because they're two separate things. So we're doing two different things. They're two different equations here. So the first equation, I get 3x equals negative 2. The second equation gives me 3x equals positive 2. And then I'm going to divide the equations by 3, and this is the same step for both equations. Now, it isn't always the same step, it just is in this case. And we get x equals negative 2/3, so you want to leave that as a fraction. And then x equals positive 2/3. So again, we have two solutions, negative 2/3 and positive 2/3. So this one, a bit larger of an equation. We've got 2k squared minus 28k plus 96 equals 0. So it's in standard form. We want to factor. And whenever you have a number in front of your first term, you want to see if you can factor out a greatest common factor. So I look at this and I see that I can divide all three of those terms by 2. So that's what I'm going to do. I'm going to divide 2 out of everything. And when you do that, that goes in front. So that gives us k squared minus 14k plus, and then just grabbing my calculator, 96 divided by 2 is 48. And then this equals 0. So when we're solving, we're trying to solve the parts with the variables. That 2 in parentheses doesn't really matter because it doesn't have a variable. If we use the zero factor property, we know that that's not 0, it's 2. So it wouldn't mean anything. So we're just focused on the parts with the variables, the k squared minus 14k plus 48. So we want to factor that. So I'm going to just set up my parentheses, and then don't forget your equal 0. And I know it's going to be a k times a k to get to k squared. So I need to multiply to get to 48 and then add to get to negative 14. So to get to a positive 48, they're both negative, and to add to a negative 14, they have to be both negative. So both of these we know are going to be negative. And I think negative 6 and negative 8 will give me negative 14 when I add those. Let's see. Yes, that will give us negative 14, and those multiply to a positive 48. So I get a minus 6 and a minus 8. And the order you put those doesn't matter. Now, if you're wondering, well, what about that 2? It just keeps dropping down in front. It just kind of starts hanging out in front there. But then when we do the zero factor property, we ignore it because if you set each thing equal to 0, you would just have 2 equals 0, which doesn't mean anything. So we get k minus 6 equals 0, k minus 8 equals 0, and then that 2 minus 2 equals 0, which is meaningless because it's just a number. It doesn't have that variable. So I'm going to solve the first equation by adding 6 to both sides, and the second equation by adding 8 to both sides. So this gives me k is equal to 6 as one solution and k equals 8 as the other solution. And often we put these in curly braces to indicate the solution set. So both of these numbers, if you replace k with them and then you follow the order of operations on the left, you'll end up with 0 on the left, and you'll get 0 equals 0, and you'll have a true statement. Here we have 6a squared minus 7a minus 3 equals 0. So this is one where, again, I'm going to look to see if there's a greatest common factor. So out of 6 and 3, I can divide by 3, but I can't divide the 7 by anything. So there's no greatest common factor, which then for me tells me I want to do the AC method of factoring versus guessing and checking. So to do the AC method, I'm taking the first term and the last term, and I'm just ignoring that minus 3. So 6 times negative 3 gives me negative 18. And then I want two numbers that multiply to negative 18 and get me to negative 7. So off the top of my head, I immediately think of negative 9 and 2. So those multiply to negative 18, and negative 9 plus 2 gets me negative 7. So I'm going to rewrite what I have. It's going to be 6a squared minus 9a plus 2a minus 3 equals 0. So I'm doing the AC method, so I split that middle term up into two separate terms. And then I group those together because now I'm going to be factoring by grouping. And I'm going to factor the greatest common factor out of each group. So between 6 and 9, I can divide them by 3, and I can also remove an a. So when I divide out 3a, I'm left with 2a left over minus 3. Since I removed the a, 9 divided by 3 is 3. And then with 2a minus 3, there's nothing in common there. So I'm going to just put a 1 in here. And I'm not really factoring anything out. I'm just putting that 1. So I'm just doing the factoring by grouping on the left when I started the AC method. And so now we've got the same thing in parentheses, which means that's our first factor, 2a minus 3. And then what's in front is our second, 3a plus 1. And this whole time I just keep copying the equals 0. It kind of keeps hanging out there. So now I've got it factored, 2a minus 3 times 3a plus 1. So we're going to use the 0 factor property. And I'm going to set each of these equal to 0. So I have 2a minus 3 equals 0. And 3a plus 1 equal to 0. And then we're going to solve for a. So the first equation, I add 3 to both sides. And the second equation, you're subtracting 1 to both sides. And I'm only doing them at the same time just so I don't have to switch colors, but usually I'll do them one at a time. So for the first equation, I got 2a equals 3. For the second equation, I have 3a equals negative 1. Then for equation 1, I have to divide them both by 2. And equation 2, I'm dividing by 3. So you want to be careful you don't get confused if you're doing them at the same time. And this gives me an answer of 3/2 and negative 1/3. So I have two solutions, 3/2 and negative 1/3. So what if you get something and it doesn't look like a quadratic and you want to try to solve it? You can still do this by factoring and using the 0 factor property. You just have to get a little creative. So I've got some examples below here of things that you can still solve. So we've got 3n cubed plus 4n squared plus n. You've got something with a whole bunch of things multiplied together. That goes straight to the 0 factor property. You've got something where part of it is multiplied, some of it's not. So let's just do a couple of these so I can show you how this works. So we have x cubed minus 8x squared minus 20x equals 0. So it's not quadratic because the highest exponent is 3, not 2. But we can still factor out a greatest common factor here. And when we do so, it will become quadratic, and then we can go through and factor and solve. So the greatest common factor here, there's an x in common in everything. So I can factor that out, which just effectively drops all the exponents by 1. And now inside my parentheses, I have something that I can factor. And just like the previous example with the 2, the thing in front, the greatest common factor, just kind of hangs out. So I need to factor x squared minus 8x minus 20. So I know that x times x gives me x squared. And then I want to multiply to a negative 20, add to a negative 10. So if I have a negative 10 plus 2, that multiplies to negative 20 and adds to negative 8. think I might have misspoken and said added to -10 or adding to -8 there. So for the zero factor property, just like I had before, everything gets set equal to 0. On the previous example, we had 2 equals 0, but now we get x equals 0, and that gives us a new answer. Then we have x minus 10 equal to 0, and then we have x plus 2 equal to 0. So we already have one solution here. I don't even need to solve that. But I do need to solve the second and third equations here. So I get x is equal to 10, and then I subtract 2 and get x equals -2. So in this case, our exponent was 3, and we got 3 different solutions. We got 0, 10, and -2. And we were able to do this by factoring. So we first factored out the greatest common factor, and then we factored our quadratic. And then we were able to use the zero factor property to solve. Here we've got 4 terms. We've got b cubed plus b squared minus 9b minus 9 equals 0. So there's no greatest common factor here. I can't factor out a b like I factored out an x because the last term doesn't have one. But when you have 4 terms, that should indicate to you you want to try to factor by grouping. So in order to factor by grouping, I need to basically group these things together. So I've got b cubed plus b squared plus, and then I'm going to group the minus 9b minus 9, and then I have that equals 0. And now I'm going to factor out the greatest common factor in both pairs. So between the b cubed and the b squared, I can factor out a b squared, which basically is removing 2 b's. So I'm left with a single b from the b cubed. And then when I divide it out of the b squared, I'm left with just 1. If you want to know why that becomes 1, not 0, you're going to want to go back to my factoring videos where I show the intermediate steps. And then the second set of parentheses, we have a -9 I can factor out. And you always factor out a negative if the first thing in parentheses is negative. So that's going to leave me with a b plus 1. And then I have this equals 0. So now both sets of parentheses match. So one of my factors is b plus 1. The other one is b squared minus 9. And then equals 0. So the b squared minus 9, that's a quadratic. We want to try to factor that more, and that is a difference of 2 squares. That's one of the special factors. That will factor to b minus 3 times b plus 3. So we have to keep factoring until we can't factor anymore. And then once you're there, that's when you use the zero factor property. So I have b plus 1 equals 0, b minus 3 equals 0, and then b plus 3 equal to 0. And again, we started with something that had an exponent of 3. We're going to get 3 solutions here. So when I solve, I'm left with b equals -1. Then I add 3 to both sides, get b equals 3. And then I subtract 3 from both sides to get b equals -3. So my 3 solutions are -1, 3, and -3. For this example, I've got something that's somewhat factored, but it's not in standard form because we need to have it equal to 0. So we have some extra steps here because we need to first get everything on one side and simplify as much as possible. And this means I have to actually distribute first and then move things, and then we factor. So when I multiply through on the left, I'm going to have 3b times b, so that's 3b squared. Then 3b times 6, which is 18b, and this equals b minus 10. So in order to use the zero factor property, we need to get everything equal to 0. So I need to subtract b from both sides, and then I'll do this in 2 different steps. That gives us 3b squared plus 17b equals negative 10. And then we add 10 to both sides because we have to get one side equal to 0. And this gives us 3b squared plus 17b plus 10 equals 0. So now we want to factor. Now this is a situation where first I would see, can I factor out the greatest common factor? There's no number in common between 3, 17, and 10. So that would say, okay, I'm going to factor using the AC method. But I actually don't have a lot of room here, so I'm going to factor by guessing and checking just in the interest of space. Otherwise, I would factor by the AC method. I know that this needs to be 3b times b to get to 3b squared. And then I'm looking for a combination. The two numbers need to multiply to 10, and then the combination needs to add to get me to 17. So if I put in a 5 and a 2, so 2 times 5 gives me 10. The insides will get me 2b, the outsides will get me 15b, and that adds to 17. So those will be pluses. And so I've just factored this one by guessing and checking, and just because I've done a lot of factoring. Otherwise, you'd probably want to do the AC method. So we've got it factored, so then we just set each factor equal to 0. So if 3b plus 2 equals 0 and b plus 5 equal to 0. And then we solve. So subtract 2 from both sides, and I get 3b equals negative 2. And then I'm kind of running out of room. This gives me b equals negative 2/3. For the second equation, I subtract 5 from both sides. I get b is equal to negative 5. So the two solutions are negative 2/3 and negative 5, which are very different from what you might have thought the solutions were if you looked at the original problem. Because if you looked at the original, you might want to say, oh, b minus 6, set that equal to 0. One of my answers is negative 6. But that's not how it works, because you have to have one side equal to 0. And when you move everything to that one side to make it equal to 0, the equation is now completely changed. It's factored completely differently. And so your solutions are actually very different from what you might have guessed they would have been in the first step. So this is solving by factoring in a nutshell. If you're struggling with the factoring part, I strongly recommend going back to last week and reviewing all of my factoring videos. I have videos on nearly every single type of factoring that I've mentioned here. So if you're going through this and I said I do the AC method and you're not sure, you can go back to the videos and watch the factoring on that method. The new stuff that you're learning this week is to what you do after you factor. That you basically set each thing equal to 0 and then solve. So if you have any questions, you know how to reach out to me, and I will see you guys at the next live.